we are handling the complexity of a design process in an effective manner, it will mainly going to reduce us the number of errors. We are dividing the problem into number of sub-problem. After finding a solution of each sub-problem, it needs to be integrated. So that is what conquer. Abstraction is a methodology to represent the essential features by hiding the background details. When we are going to maintain the abstraction, or when we are going to maintain the confidentiality of a data of a software or a system, then we can say that as a data abstraction. Hello everybody, a warm welcome to one and all. Welcome to the very first session of Unit 3, and we are in the B.C.A 6th semester, subject called Software Engineering. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we are going to see about this Unit 3, that's all regarding design concepts and coding. So as we all know that up to the second unit, we got to know what is feasibility study. So before to that, first we got to know what is SDLC, System Development Life Cycle. So in order to develop any of the software or a system, we have to follow certain stages or phases, right? So in that we got to know first we have a feasibility study, whether it is possible to implement or not. So once it got okay, after that we have to collect the requirements. So that requirement will going to be collected by the different stakeholders. So from the different stakeholders, analyst or a designer will going to collect all the requirements. So by collecting all the requirements, we are just going to do the analysis of that requirement, and we have a software requirement specification. It can be functional requirement, non-functional requirement. So everything which is got over, which is related to the requirement collection. And also in the previous unit, we got to know regarding the system analysis, how analysis model will going to work and how analysis will going to be takes place, everything that we got to know that. So after the analysis, next we have a design part. So in our today's session, along with our unit 3, we are going to learn about the designing part as well as coding. In our today's session, we are going to learn about the software design principles. So if I wanted to design any of the software, then what are the principles we have, how it will going to be helpful, that is what software design principle. And also we'll see about the some of the elements of the software design principle. So partition of a problem will be there, and abstraction is there, modularity will there. So we'll see each of the concept one by one. Let me get into the first topic, that is regarding software design principle. As I discussed earlier, first analysis has been done, that needs to be converted into some architecture or a structured representation of an analyzed requirement. So for that reason, we are going to have this software design principle. Then how it will going to be helpful, for what reason we have to use this, you will see here. Software design principles are concerned with providing means to handle the complexity of a design process effectively. So here this software design principle will going to help us in order to maintain or in order to handle the complexity when we are designing any of the software. So for example, if I wanted to design any of the software, first I must have a well-mannered or well-structured analyzed requirement. With the help of that only we can do the designing part. So in order to reduce that complexity, or mainly in order to handle that complexity, we can have this software design principle in an effective manner. And also when we are maintaining it, or when we are handling the complexity of a design process in an effective manner, it will mainly going to reduce us the number of errors, and also it will going to improve the efficiency of a software. For that reason, it is necessary to have this software design principle. Then here you can see that here we have certain principles of software design. So when we are designing a software, at the time mainly to handle the complexity of a software or a system, we are going to use this software design modeling or a principle. So when we have this software design principle, or when we have this software design modularity, at the time it will going to handle the uncertain errors which will going to occur during the development of a software. So here you can see that here we have a following number of principles of software design here. First we have a problem partition, It should not be considered as a single problem. So that is what problem partition. In the second term, we have a abstraction. Whatever is necessary for the user for the usage of software, only that number of elements should be seen to them. That is what abstraction. I will discuss about each part one by one here. As of now, you just understand we have 4 components or 4 principles of software design that we have. First is regarding problem partition. Once it got partitioned, next we need to maintain the abstraction. Then we have to be concerned regarding this modularity. After that, that modular approach can be either top down approach or else it can be bottom up strategy. It can be any one of this, top down, either bottom up. We are going to see about each type of strategy in my coming session. So now these 4 are the principles of software design approach. So now you can see that regarding the problem partitioning. So mainly, for example, when you wanted to build any of the software or a system or product, anything it can be. So at the time, we can't expect all the time a small problem or a large program or average kind of problem. We can't expect the kind of problem that we are going to face. So that when it is of small problem or when the size of a problem is small, at the time it can be handled in a easy manner. But what if it is complex task, or what if it is large program or a large problem? At the time, that needs to be divided into number of problem. So that is what we are going to call that as a problem partitioning. So for a small problem, it will be easy to handle, but for the large program or a large problem, that needs to be divided into number of sub problem, and we have to find a solution for each sub problem individually. At last, we have to collaborate or to integrate all the solution. You just imagine, here I have a complex task or a complex problem. So instead of handling it individual manner, I will be dividing it into number of sub problem. So after that, we are going to find the solution for each sub problem. At last, I will integrate or I will collaborate all the solution of the sub problem. Then we can find a solution or we can get the solution for the complex task. This is what mainly regarding partitioning of a problem. Mainly, we should not consider a problem or a number of requirements as a single unit. It needs to be divided into number of sub-problems. So, divide the problems and conquer the problem. It means to divide the problem into smaller pieces so that each piece can be captured separately. So, we are using divide and conquer method. So, which method we are using here? We are using divide and conquer method. So, divide in the sense, we are dividing the problem into number of sub-problem. After finding a solution of each sub-problem, it needs to be integrated. So, that is what conquer. So, divide and conquer method is used in order to maintain or to handle the complex problem which we are going to face in a development of a software at the time of its designing phase. So, that for the software design, the goal is to divide the problem into manageable pieces. So, when we have a manageable pieces, at the time number of errors is also going to be less and we can get the more productive sub-problem solution. Along with that, we can integrate all those sub-problem solution in order to get a solution for the complex task. This is mainly regarding problem partitioning. So, after that, next, what are the benefits that we can expect when we are partitioning the problem? Here you can see some of the benefits. Software is easy to understand. Instead of learning it as a bulk amount of complex tasks, if we have divided that into number of sub-tasks or a number of sub-problem, at the time it will be easy for the understanding, and also software become simple. Obviously, if it is easy to understand, it needs to be simple, and software is easy to test. Instead of having a complete test of a software, it is helpful and it will be easy to have a unit testing. Each module or each sub-problem will going to be tested individually, so that testing of that software will be easy. And also it will be easy for the modification. So, in order to modify, it will be of easy thing and it is easy to maintain. So, when it is of different or when it is of simple module, then for the maintenance also it will be easy and easy to expand. If I wanted to add some more sub-problem or a sub-partitioned model to the existing system or a software, then it will be easy to expand or to extend. And also we can use this partitioning or problem partitioning method in the Java try-catch method. So here you can see that. So when we have a minimum number of partitions, or when the number of partitioning or sub problem is increases, at the time the cost of partition and complexity is also going to be increased. So that means when we are partitioning the problem, it should not be like a minute number of partitioning. So if it is necessary, then only we have to make a partition. If we are increasing the partitioning of a problem, then it will also going to increase the cost of that partitioning. Along with that, complexity is also going to be increased. So when we are partitioning the problem, we have to be very conscious. So these are the benefits along with the problem partitioning. So what is the next thing? That is related to abstraction. So mainly abstraction in the sense what? Already you know how to use washing machine, how to use WhatsApp or any of the social media, and also we know how to operate any of the electronic gadgets. But do you really know how it is working internally? Somehow no, right? Why? Because when they are designing, at the time they are just going to give the essential features to the user by hiding the background detail which is not useful for the user and which is not necessary for the user to get to know. So mainly what I wanted from the social media, I just wanted to communicate with the people. So can I do that with the help of social media? Yes. Then why should I bother about how it is implemented or what are the methodology they are using? People will won't bother about how it is working internally. Instead of that, they will bother or focus about how to operate it. That is what this abstraction is all about. So the abstraction is a methodology to represent the essential features by hiding the background details. We no need to bother about how it is working internally. Instead of that, we have to concern regarding how to use it or how to get the benefit out of that. So in the same way, when we are designing any of the software or a solution, at that time we should not bother what are the algorithms they are using, what are the methodology they are using, how they are doing the designing, which kind of methodology they are using. Instead of that, that will just showcase us how to design or how to get the benefit out of that. So that abstraction is a tool that enables a designer to consider a component at an abstract level without bothering about an internal details of the implementation. Even designer should not bother about how it will going to be implemented. So once it is designed, then only it will be gone for the implementation. So being a designer, they should not bother about how it will going to be implemented. Instead of that, they have to simply design. They should not bother about internal details of the implementation, so that abstraction can be used for existing element, and also I can use it for component which needs to be designed. It can be used for the existing system as well as we can use for the system which is under development. That is related to abstraction. Then what are the types of abstraction we have? It can be functional abstraction and can be data abstraction. There are two types of abstraction we have in the design principle. Under that we have a functional as well as data abstraction. We'll see the functional abstraction here. So already we know that we have two kinds of abstraction, functional as well as data abstraction. And already you know about the thing called function, right? If it is a set of instruction which we are writing in order to get a particular solution, or which we are writing a set of code of lines to perform a particular task, then we are going to call that as a function. So if I wanted to write a function, at the time I have to do the coding. So before coding, we have a flowchart. Before to that, we have a algorithm, right? So algorithm will be converted into flowchart. Flowchart will be converted into some set of lines of code. So in the function, so function mainly defines what? It defines the method. It defines the behavior of a problem, or it defines the behavior of a program or a set of block of code. So here when we are specifying only the usage of that module, instead of showcasing what are the algorithms we are using, how it is implemented, how many number of lines of code we are using for that, so it will going to abstract all the algorithm and how it will be implemented and what are the methodology we have used. So all those will going to be abstracted. Then we can say that as a functional abstraction. So that a module is specified by the method it performs. So method is nothing but function and its behavior, so that the details of the algorithm to accomplish the functions are not visible to the user of the function. As I told earlier, we are maintaining the confidentiality and only the essential part will going to be get to the user of a function. They are not going to see how it is working internally, what are the algorithms they are using in order to implement this function. Instead of that, they are able to use it instead of getting all the details of the algorithm which we are using. So when we are maintaining the abstraction at the time of its implementation, or what are the algorithms we are using in order to implement that method, then we can say that as a functional abstraction. So mainly it will going to helpful in order to form the basis for function oriented design approaches. So function abstraction will be helpful in order to maintain or to accomplish or to form this basis for the function oriented design approach. So we have a object oriented design approach. In the same way, we have a function oriented design approach. So when we are designing any of the software or a product based on the function, there we are going to have this function abstraction. User should not see what are the algorithms we are using. Instead of that, they must be only able to access that function or to use that function. That is what function abstraction. Next, what we have, that is data abstraction. So here, when we are going to maintain the abstraction, or when we are going to maintain the confidentiality of a data of a software or a system, then we can say that as a data abstraction. So that details of the data elements are not visible to the user of data. So they won't get to know what is the source of a data, from where we are getting, from whom we are getting. They won't bother, and it will not going to be showcased to the user. So everything will going to be hidden, or it is not visible to the user of that data, and data abstraction will going to be formed as a basis for the object oriented designing approach. So that is OOD. So that means object oriented design approach. So here this function abstraction is helpful for the function oriented design approach. Data abstraction is helpful for the object oriented design approach. So this is regarding abstraction. So now we got to know regarding problem partitioning and usage or benefits of problem partitioning, and also we got to know regarding abstraction, that is the second type or second principle of design approach, and types of abstraction that we got to know. So next we'll see about the third component, that is regarding modularity. Already I told you, right, when we have a problem or a complex problem, that should not be considered as a individual task, should be divided into number of sub problems or a sub modules. So that is what modularity. So mainly it will going to specify to the division of software into separate modules. So here we are not considering the complete software as a complete task or a module, that needs to be divided into number of sub modules. So why we have to do that? Mainly to reduce the complexity in order to improve the efficiency and effectiveness of a software. So which are differently named and addressed and are integrated later on to it obtain the completely functional software. So here also it's like a problem partition itself. So complete software will going to be designed into number of modules. Let me consider that as M1, M2, M3. So after that, I am going to integrate all these together. We will add all these together to find the solution or to build the software. And also when we are dividing this module to number of modules, or when we are dividing the software into number of modules, at the time each module will going to be dependent on other. So that means it's not so independent. It will going to be depend one on another way of the other modules which we have in the software development. Mainly that allows a program to be intellectually manageable. So when we are having this modularity, mainly it will going to helpful in order to manage or to have the intellectual manageable parts of the software. So you just imagine I have 2500 lines of code in order to develop any of the software. So there, will it be easy for you to remember all the codes, or will it be easy for you to understand the all number of lines of code? Somehow it is difficult, no? Why? Because it will going to have n number of variables will be there, and constants will be there, even reference variables, control paths along with the global variables, all those will be there in a large program. So in order to make that understand, and in order to make that large programs to be easy, there we are going to make a modularity. So that means we are dividing the problem or a program into number of sub-modules. That is what we are going to call that as a modularity. Now here you can see some of the properties of this modular system. So what are the benefits or properties that we can see here? Each module is well-defined system. So here all the modules are well-defined system that can be used with other application. For example, here I am going to divide this module into M1 and M2. For if I wanted to create another application called N, at the time I can integrate this M1 and M2 in order to develop N. So that means each module is well defined, no need to do testing, no need to do the compiling, everything is done already, it's ready to use. That means it's instant module. So everything is what? Well defined system, so that it can be used with other application. If I wanted to develop any other application, there also I can have this modularity approach, and each module has a single specified objective. So if I say M1, this M1 will going to give some resultant or a specific resultant. It is not what subjective in nature, it is objective in nature. That is what each module has a single specified objective. Each module will going to give some productivity with respect to some particular objective. And also modules can be separately compiled and saved in the library. As I told earlier, each module will going to be compiled separately and each module will going to be tested separately. Everything will going to be done individually. So if I wanted to use or if I wanted to have this M2 to my another application, I can take it instantly. No need to bother about compiling it or designing it or to testing it separately. Everything is already done. Mainly we have to use it for the development of a software, and also modules should be easier to use than to build. So all these are somehow difficult to build, but for the usage it will be easy, and modules are simpler from outside than inside. So if you are just looking into M1 and M2 and N, so for looking into that, modules will be easy from the outside, but when we have a inside process or functionality of that module, somehow will be difficult. So when we build that well mannered or well maintained or well defined system in a efficient manner, then we are going to save this in the library. That means instead of developing it again or to compile it or to test it again, simply we can have it in our software development. So these are the properties that we have to consider with respect to this modular system. Then what are the advantages we can expect from this modularity? We'll see. It allows large programs to be written by several or different people. So just imagine I wanted to find a solution or I wanted to have a solution for last 5 years question paper, right? Already you know the exam pattern and all the question paper pattern, right? So instead of giving that 5 years question paper solution to write the solution for that 5 years question paper to a single student, instead of that, I will just going to make a group of 3 students as a 3 batch, or I will make a group of 3 students as a 5 batch. Fine. So then I am going to give first year's question paper to them and previous year's question paper and another year and for one more year. So totally I will give one year question paper to 3 set of students. That means group of students will be there. So at that time, what it is mainly useful for the partitioning of that problem or to do the modularity, so we can get the solution instantly, and burden will going to be very less for a particular number of people. So in the modularity also, whatever the large program we have, that can be written by several or different people. So all those will going to be combined together in order to yield a solution. And also it encourages the creation of commonly used routines to be placed in the library and used by the other programs. So here we are mainly focusing on the recently used, commonly used routines which we are using in a daily life or which we are using frequently. That kind of modules will going to be developed and it will be compiled, tested independently, everything will going to be done. It is ready to use. So regularly using or frequently using or commonly using routines will going to be stored in the library. At the time when we have the modularity or when we have modules or ready module in the library, no need to write it or no need to do it from the scratch. Simply we can use it. So we can use by the other programmers and it can be used in the other applications also. And also it simplifies the overlay procedure of loading of large programs into main storage. So when we are dividing the problem into number of sub-modules or a sub-problem, at the time overhead to the memory or a computer's memory will be somehow less. So that is what we are dividing that into number of modules. And also mainly it provides more checkpoints to measure the progress. Mainly it will going to have more checkpoints. So if we have more checkpoints in the program, then it will going to improve the efficiency of that program, so that we can measure the progress if the number of checkpoints are high. And it provides a framework for complete testing and more accessible to test. It will mainly support the framework, or it will going to act as a framework for complete testing. So we can have a complete testing in unit testing, integrated testing, system testing, all those together can be done, and it will going to act as, or it will provides a framework for that testing. And also it produces the well designed and more readable program. So mainly it is divided into partitions or modules. So it will be easy for understanding and for the purpose of reading and to design that modularity for the development of a software. Everything will going to be easy. So these are the advantages we can expect. Then what are the disadvantages we have in the modularity? Execution time may be, but not certainly longer. So somehow the execution time will going to be longer. Why? Because if we have a large program that will be divided into number of modules and I need to integrate all the modules, so it will going to take some more time, so that storage size will going to be more. So but it is not certainly will going to be increase. So if you have a number of modules, if you have more number of modules, then the storage space requirement is also going to be high, and compilation and loading time may be longer. So when we have more number of modules, that needs to be what integrated together, and each module should be compiled, tested, so that for that reason compilation as well as loading time will going to be high. Along with that, inter-module communication problems may be increased. So if there is no compatibility between the one module to another module, at that time there is no compatibility, so the some kind of problems may going to be increased when there is no compatibility. And also more linkage required, runtime may be longer. So here I wanted to integrate one module with another module. At that time linkage time will going to be high. Even loading time and linkage time both will going to be increased. If it is increased, even runtime is also going to be increased, and more source line must be written. So we have to write more source code. That means a program which is written by the programmer needs to be high. Why? Because we have an individual model, but if wanted to integrate all those together, I have to write a code for that also. So that, and more documentation has to be done. So which module is in the library, what is its working procedure, for what reason we have done it, everything needs to be documented and it needs to be maintained. All these overhead can be in the place of modularity approach. So these are the modularity benefits, properties along with the disadvantage. I hope you all understood. It's all about our today's session. In my coming session, we're going to see how we are going to design this modular approach, that is modular design, and also we'll see about the strategy of design. It is of top down as well as bottom up, and also we have certain methodology that I will be discussing in my coming session. Along with that, we'll see the difference between the structured and object oriented analysis. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.